Okay, we'll go ahead and get started this morning. Again, thank you very much for joining us on our Hurricanes at Home webinar series. Again, my name is Dan Brown. I'm one of the senior hurricane specialists at the National Hurricane Center, broadcasting to you again from my home here in South Florida. I'm joined by a distinguished panel of meteorologists that will help answer your questions and talk to us this morning. I'll introduce them in just a moment. A couple reminders about the webinar. One is there is an opportunity for you to ask questions in our question box. I see a few people have found that already and have made a few comments. We will be answering some of those questions during the webinar, but we'll save a lot of those for the end. The webinar will work that we'll have about half the period this morning, about 30 minutes is presentation, and then the other half will be our question and answer period. So hopefully we can get to a lot of your questions. I know based on recent history that we won't get to every single one of those that you ask, but we'll try to get to as many as we can. So please ask those questions for our distinguished panel this morning. So with that, I'll ask Robbie to turn it over to the first slide, showing that unfortunately, Georgia and the Carolinas is no stranger to hurricanes. Hurricanes have affected these areas, both the coast of these areas and then also the inland sections, bringing heavy rainfall. You go all the way back to 1989 with Hugo that struck Charleston as a Category 4 hurricane, did a lot of devastation from not only wind but also storm surge. And we're going to talk about all these hazards this morning. But then other hurricanes like Hurricane Floyd in 1999 struck the eastern part of the Carolinas. And then more recently, we've seen storms such as Matthew and Florence. Florence being just a couple of years ago, bringing all that heavy rainfall to the eastern parts of the Carolina. And this morning, we're going to talk about how we forecast hurricanes, how we observe hurricanes, and then also those hazards that we have to be aware of when hurricanes are threatening our area. So the next slide will show all the folks that are on with me this morning. So the first person I'll introduce is Robbie Berg. Robbie is another hurricane specialist at the National Hurricane Center. He's going to get through the first part of our presentation this morning. We also are joined by Nikki Hathoway. Nikki is one of the flight meteorologists as part of the NOAA Hurricane Hunter aircraft, and she flies right into hurricanes, helping us provide that data and help us with our forecast at the National Hurricane Center. Also, I'm joined by John Cangialosi. You don't see John's webcam yet, but John is on here with me this morning. He's going to help moderate our question and answer period. He's also a hurricane forecaster at the National Hurricane Center. Also joined by Carl Barnes. Carl is from the local National Weather Service office in Morehead City in the eastern part of North Carolina, from the coastal office there. And he's going to talk about what they do at their office and also, again, how our team works when a hurricane is threatening an area. Also joined by Andy Latto. Andy's another hurricane forecaster at the National Hurricane Center. He's going to talk to you about the second half of our presentation about some of the hurricane hazards and how we forecast them this morning. And last but not least is Frank Alsheimer. Frank is also from the National Weather Service office in Columbia, South Carolina, an inland office. Again, hurricanes aren't just a coastal event, they also affect inland areas as well. So Frank will talk about what they do there. And he also worked at the Charleston office previously, so he's experienced with both, again, hurricanes at the coast and inland. So with that, let's get right started with the presentation, and I'll turn it over to Robbie.
Hey, thanks, Dan. So you're going to notice on your screen, we're going to pop up with a question that I want everybody to think about, because as Dan said, that all of us on this panel are meteorologists, but do you actually know what a meteorologist is? What does a meteorologist do? So the answer to that question is a meteorologist is someone who studies or forecasts the weather. And you can see on your screen there are some different examples of meteorologists doing their jobs. So there's some examples of meteorologists, say, working at the National Hurricane Center, making forecasts for where a storm is going to go. We have sometimes meteorologists do media interviews. We have some meteorologists that are on TV. And there's a whole host of other types of meteorologists as well that aren't shown on the screen. So lots of times when people think about people that do weather, that study weather, you think about TV, with the people you see on the evening news giving the weather. And that's just one type of meteorologist. There's lots of other meteorologists that are often behind the scenes that you never get to see. And what they're doing as well is also studying and forecasting the weather. So and I bet that there's some kids out there that are listening to us today that they want to be meteorologists. And we want to hear from you because we think this is a really cool field to be able to study as you kind of pick what career you might want to take. So I mentioned the National Hurricane Center, and that's where many of us on this panel work. So we want to say good morning from Miami, Florida. That's where we're located. There in the southern part of the state of Florida. And what you're seeing on your screen here are some pictures of what our building looks like where we work in Miami. And you might be saying, wow, that's a lot of concrete. Well, yeah, the building is actually made of very strong concrete because South Florida can be prone to strong hurricanes. And so if we're at work during a hurricane, we need to make sure that we're in a very sturdy building that's not going to fall down when we get a strong storm. So for that reason, the building was built with very strong concrete and steel to make it strong against those winds. You can see that here on the screen. We're saying that we forecast for hurricanes not just over the Atlantic Ocean, where most of us are worried about, but also over the eastern part of the Pacific Ocean as well. So we have a really large area that we're watching for these types of storms to form, and then we're forecasting where the storms are going to go and how strong we think they're going to get. Now, another function that we have with the Hurricane Center is for people that work or live out on the water, especially out on the ocean. So we have a unit at the Hurricane Center that produces what we call marine forecasts. And what those are doing is they're telling boaters, big ships, and other people who spend time out on the ocean what the weather is going to be like where they are. So you can see that maybe you take a cruise, or maybe you or your family own a boat and you take it out onto the water. Sometimes people even live and work out on oil rigs out over the ocean. All of those people need to know what's the weather going to be like and what are the wave conditions going to be like on the ocean. So one of the functions of the Hurricane Center is to provide those wind and wave forecasts over portions of the tropical oceans, including off the parts of the southeast coast of the United States and the Gulf of Mexico. So the Hurricane Center is actually part of a larger organization called the National Weather Service. And you may have heard of that term before, National Weather Service, but if we're in Miami, where is the National Weather Service? Well, as you can see on the screen, which is a map of the United States, the National Weather Service is actually everywhere. Everywhere across the country, wherever you live, there is a National Weather Service office that makes your forecasts for where you live. And that's where some of the panelists that we have here today, they work in some of these local weather service forecast offices in parts of the southeast United States, in the Carolinas. So we're going to turn to each of them real quick to give a rundown of what they do in their office. And first, we're going to go to Carl from the Morehead City office, who's going to talk about what they do there. So Carl, take it away.
Hey, yeah, thanks, Robbie. So here in Morehead City, we cover a large portion of eastern North Carolina. So we're really focused on hurricanes. We're focused on coastal threats, especially it's a very low-lying area. So we're always, especially ahead of hurricanes, we're working with the National Hurricane Center to refine our forecasts and really give people the information that they need for their specific communities to help keep them safe. Ahead of the hurricanes, like this time of year, we're starting to worry about hurricane preparedness. So we're helping the communities build resiliency, and we're helping them think ahead of time, when and if we do get a hurricane, what do we need to be doing? So we're really active in the community and trying to get out and meet people in person and get the word out. We've had several storms that have hit us here over the last couple of years. We've gotten major effects from Dorian and from Florence before that. And we actually have the Outer Banks is climatologically the most frequently impacted portion of coastline in the continental United States for hurricanes. So we are really, really closely connected with the Hurricane Center, and we work with them a lot.
Thanks, Carl. Now I'm going to turn it over to Frank, who is going to talk about what they do in his office in Columbia, South Carolina.
With Columbia in the inland area, we don't have the same storm surge threat that Carl has to deal with in his area, but we do have flooding, tornadoes, and wind that can all occur as major impacts from hurricanes. Another unique thing about our office is that we are located in the capital of the state of South Carolina. So we send folks over to the governor's office and the state emergency operations office to help with them for planning for the entire state of South Carolina and the impacts of hurricanes. We, of course, deal very closely with the Hurricane Center. They make the forecast for track, and then we refine the forecasts into very localized areas such as cities and towns for exact impacts for them. And you can see we have about 20 meteorologists, electronics technicians, and support staff to help us all put together a 24/7 operation.
Hey, thanks, Frank. Yeah, so all of you guys that live in the Carolinas and Georgia, you may have been experiencing or will be experiencing some bumpy weather today, and both Frank and Carl's offices are busy watching the weather with thunderstorms that are moving through today. So it doesn't matter if it's hurricane season or not, Frank and Carl's offices are providing you forecasts on every day of the year. So they're very critical parts of the National Weather Service. So let's move on now to talking about hurricanes themselves. And hopefully what you're going to see on your screen here is a satellite image of a hurricane. This happens to be Hurricane Harvey, which made landfall in the state of Texas several years ago. And we're showing you this satellite image because there's a few things we want to point out. First off, what's the first thing that you see when you look at this satellite image? I'm guessing it's this center part here where it looks like it's clear. You see all these clouds, and then right in the center there, it looks like there's nothing. It's almost black. Well, that's what we call the eye of the hurricane. The eye is kind of a strange place because when people think about hurricanes, they think about really strong winds, very heavy rainfall, and so forth. But in the eye of the hurricane, when that moves over where you live, the wind actually goes calm. So the wind's just not blowing at all. Or if it is blowing, it's very light. And the rain will stop. So it's kind of a weird thing is that when a hurricane is that bad, that strong, how can you have that center part there where the winds go calm? So it's really cool. And when we talk to Nikki in a little bit later in the webinar, she's going to talk about experiences of actually flying into the eye of a hurricane when they're trying to collect data. So it's a really interesting part of the hurricane. Not only do we have to worry about the eye, right around the eye is what we call the eye wall. And that's where you get the very heaviest rain, the strongest winds. So that's the worst part of the hurricane in most cases. Then as you move out away from the eye wall, you see these other clouds and rain bands. Those are the outer rain bands or spiral bands, as we call them, where you can get bumpy weather, you can often get even tornadoes, but the weather out from those parts of the hurricane actually tends to go up and down. So you might get a little bit of bad weather, and then it'll calm down a bit, and then another band will go through and the weather will get bad again. So it's kind of like an up and down roller coaster when you're in those outer rain bands. And then as the center of the storm gets close to you, weather conditions just get worse and worse. So that's the general kind of structure of a hurricane. And that's what we're looking at when we look at these satellite images to try and identify the different parts of the hurricane. Now, you may have heard us talk about categories when it comes to hurricane. And the categories that we talk about are the ways that we group hurricanes, because there's all these different storms out there, and we have to find ways of telling people what to expect with the storm. So these two men that you see on your screen, Herb Safford and Robert Simpson, they were actually a team. One was an engineer and one was a meteorologist. And so the meteorologist could forecast the weather, and then the engineer, Herb Safford, would say, okay, well, based on the winds of the storm, what kind of damage do I expect from that hurricane? So what the two of them did is they came up with this scale, which you can now call the Safford-Simpson Hurricane Wind Scale, which categorizes or groups hurricanes based on the strongest winds that are within that storm. So you can see that once a hurricane has 74-mile-per-hour winds, we say it's Category 1, and it can produce some wind damage. All the way up to Category 5, where the winds get to 157 miles per hour or stronger. And at that point, those types of winds can cause catastrophic damage. So we use this scale 1 through 5 to group these hurricanes based on how bad their winds are. Now, the one caveat, the one thing I'll say about this, though, is that it's only about the wind. It doesn't say anything about the other hazards that can come with the storm. And we're going to talk about those hazards when we get to the second half of this talk. So keep thinking about what might come with the storm besides the wind. When you get a Category 3, 4, or 5 hurricane on the scale, that's what we call a major hurricane. So what you're looking at now on your screen is a map of the Atlantic Ocean. All of the yellow lines are where a major hurricane has moved across the ocean or the Gulf of Mexico or the Caribbean Sea. So what do you notice? Well, anywhere here in the western part of the Atlantic Ocean, very close to the east coast of the United States, including the Gulf Coast and down into the Caribbean, all of these areas have seen major hurricanes. So everywhere that we live is vulnerable to getting these strong storms. In fact, parts of Florida, and then I think even as Carl mentioned, parts of East North Carolina are kind of the hot spots for these storms. It's the areas where we tend to see a lot of hurricanes move, and they can be strong ones in those category 3, 4s, or 5s. Now let's take a little bit closer zoom into the area where you guys live. First, let's take a look at the state of Georgia. And what you're seeing on your screen now, or what you should be seeing here shortly, is a map of the state of Georgia. And all of those lines are where we've had a hurricane move across the state since the year 1900. Look at all those lines. And what I want you to notice is that in the state of Georgia, you don't necessarily have to be living down here right along the coast in order to see a hurricane. There are a lot of lines that have moved up through the southern and central part of the state, and a lot of these hurricanes actually come from the Gulf of Mexico. So it's not just the Atlantic coast we have to be worried about, but even down south across the Florida Panhandle, we need to be watching these storms coming up from the south. One of those ones that occurred recently was Hurricane Michael in 2018, which hit the Florida Panhandle as a category 5, and that hurricane maintained its major hurricane status all the way up into southwestern Georgia. So again, don't just worry about the coast. We're also worried about inland areas, not just because of the strong winds, but also because of the heavy rainfall. Now let's move up the coast to South Carolina. Now you're going to see even more lines. So the state of South Carolina has been hit by a lot of hurricanes. And again, those hurricanes can move well inland, not just at the coast. This one line here, you can see it goes from purple to orange as it heads into North Carolina. That was Hurricane Hugo. So that storm made landfall in the Charleston area, but even when it moved into Frank's area here in the central part of the state in Columbia, it still had very strong winds as a hurricane, even when it made its way up into North Carolina. So these storms can move very far inland with hurricane strength winds. And last but not least, we go up the coast of North Carolina, and you can see, again, lots of storms, especially in the eastern part of the state. We get a lot of hurricanes in that part of the state because if you look at the map, North Carolina kind of juts out into the Atlantic Ocean a bit. So as storms ride up the coast, it's very hard, I guess, you want to put it this way, to stay out of the way. The land there of North Carolina kind of, because it does jut out into the ocean, can get hit by those hurricanes that recurve over the western part of the Atlantic Ocean. So I don't think you need me to tell you that all 3 states, Georgia, South, and North Carolina, are vulnerable to hurricanes, and we've seen lots of hurricanes in our histories. So we always have to be prepared for these storms. So now what we're going to do is we're going to do a quick pop quiz. So we're happy for you guys to watch us give this presentation, but we wanted you to be involved as well. So what I'm going to do is I'm going to read this question, and I'm going to turn it over to Dan, who's actually going to open up a poll and allow you to select your answer. So here's the question. When is Atlantic hurricane season? Is it A, May through November, B, December through April, C, June through November, or D, all year long? So Dan, would you please open up the poll?
Sure, Robbie. I just opened the poll. See, folks are voting. So please vote on the poll that should pop up, but it may not pop up for everyone, but hopefully it will for you. I know some people like to vote in the question box, but if you vote on the poll, then we see the results. And this may be our smartest group ever, Robbie, because we're getting a lot of folks that have the right answer.
Awesome.
I see looks like about most everybody has voted by now, so I'm going to close the poll here in just a second. I'll go ahead and close the poll and see if I can share those results. So based on what I said a second ago, I'm going to give the right answer here, but it looks like about 3/4 of everybody selected June through November. So really great responses there. And then 16% said May through November. So let me throw it back over to you.
Okay, yeah, thanks, Dan. So, wow, really great job, guys. So the correct answer here is actually C, June through November. That's when the Atlantic hurricane season is officially. Now, if you said May through November, we're not going to say you're totally wrong, because sometimes we can get storms before June 1st. Seems like almost every year we're seeing systems out in the Atlantic or in the month of May that we're at least watching. So it's often, sometimes the season can start a little bit early. So even though the official answer here would be C, June through November, I think we'll take the answer May through November as well. So here's an example of a snapshot from one hurricane season. This was a couple of years ago, actually in 2018. Again, the season runs from June 1st to November 30th. And this was a date in September of 2018 where we happened to be really busy at one time. You can see on the screen, it's a satellite image of the Atlantic Ocean, and you're probably drawn, your eyes are probably drawn to several different cloud features here across the Atlantic. I count 1, 2, 3, 4, even maybe 5 areas of cloudiness that maybe are hurricanes. Well, when I look at them, yeah, it looks like here we actually had Hurricane Florence, which was going to end up impacting parts of the Carolinas in a few days. We had Isaac down here approaching the Caribbean. We had Hurricane Helene out here in the eastern part of the Atlantic, and then even another system here just emerging off the coast of Africa. So, you know, sometimes in the hurricane season, we can get really busy and there's lots of different storms that we're watching all at once. And you have to make a forecast for all those storms. It can be a very busy shift when we have to go in and work. So you see that, again, this was September. So the question might be, okay, when do you see the most hurricanes? If the season runs from June 1st through November 30th, when would you see the most? And what you see on your screen now is what we like to call our campfire graph or campfire diagram, because it looks like a flame if you were to have a campfire out in the woods. And what you'll notice here is that here's June 1st, here on the left side of the figure, and the flame kind of goes up as you're going through time, and you get a peak here around September 10th. And then after September 10th, the flame starts to go down again until you get to the end of the season here November 30th. So we tend to see most storms around the middle of September. It doesn't mean that every September is busy, but when we take all of the years and put them all together, we see the most storms in the month of September, as well as the months that border that, August and October. So those 3-month periods, August, September, and October, is when we really have to be watching the Atlantic, because that's when we tend to see the most storms. Let's take a look at another question. Now, we're not going to open the poll for this one, but I do want everybody to think about this question. And if you think you have the answer, maybe you can just shout it out loud so that your whole family can hear it. So here's the question. What are the primary hurricane hazards? Is the answer A, high winds, B, storm surge, C, heavy rainfall, D, dangerous surf, or E, all of the above? So what do you think? Shout out your answer. So the answer to this question is actually E, all of the above. So every one of those things that you see there on your screen, the winds, the storm surge, the rainfall, and the waves and surf at the coast are all very important when it comes to hurricanes. And so we're going to go through each of those now to talk about why they're each important. But first off, what I want you to do is I want you to remember a word that's going to help you to remember each of these hazards. And that word is SWIFT, S-W-I-F-T. As you can see there on your screen. Each one of those letters stands for a different hurricane hazard. And I think this word will help you to remember each of those hazards the next time a hurricane might threaten your area. So first off, the S in SWIFT stands for storm surge. Storm surge is when the wind from a hurricane pushes the ocean water, or in, say, North Carolina, the Sound, say Pamlico Sound, they can push the water from the Sound onto land. So places along the coast can be vulnerable to the ocean water being pushed onto land, and that's what we call storm surge. The W in SWIFT stands for wind, and that's what most people think about, is the wind. The strong winds in a hurricane can blow things around or damage homes. So that's what the W stands for. Now the next two letters, I and F, are actually combined and they stand for inland flooding. So while we can see flooding from the ocean in storm surge, you can actually also see flooding from the heavy rainfall in these storms. And that's what we call inland flooding. Last but not least, the T in SWIFT stands for tornadoes. We all think about tornadoes as these storms we see out in the Midwest, or even many of you guys in the southeastern United States have had tornadoes over the past couple of weeks. Well, we can often sometimes see those tornadoes with hurricanes as well. So remember, SWIFT stands for all those 4 hazards. Now there's one more hazard that's not in that word, and that's the waves and rip currents that can occur along the coast, even well out ahead of a hurricane. And again, Andy's going to talk about that hazard along with all the others as we move forward in this presentation. So I've got one last quiz that we're going to throw to you guys before I do hand it over to Andy. And here is that quiz. And we are going to open this one up for you to vote. So which hurricane hazard has caused the most deaths in the United States? Is the answer A, wind, B, storm surge, C, flooding, or D, tornadoes? So Dan, if you could please open the poll up again.
Okay, thanks, Robbie. I have the poll open. Looks like folks are getting the hang of answering the questions on the poll. I see a lot of answers coming in. I have to add, Robbie, before I sign off here, that I wore my Carolina Blue Hurricane Center shirt today. I know we have a couple of NC State graduates on, so you guys might be saying boo at the moment, but when I grew up in North Carolina, I was a Tar Heel fan.
Yeah, go Pack.
Let me get ready to close the poll here. It's a really close race between 3 of the answers. So let me go ahead and see if I can share those results. So a third of the folks said flooding, almost a third said storm surge, and about a third said tornadoes, with wind coming in at the very back of the pack. So with that, thanks, Robbie. I'll turn it over to Andy, who's going to take us through and give you the answer, and then take us through the second part of the series. And I saw that Wolfpack hat there, Robbie.
Thanks, Dan. Hopefully everyone can see my screen here. So there was a very, very close race for the answer to this. It's a really tough question, actually. My parents got it wrong last week, and I've been a meteorologist for how many years? So I guess I need to educate them a little bit. So the correct answer is storm surge. And so storm surge, why is storm surge the most hazardous for deaths in the United States? Well, I'll get to that in a minute. See, when I grew up, I lived a little bit inland, that's a few miles inland, and I lived about 30 feet above sea level. So when a hurricane approached, wind is what I thought about, because wind there would be my the biggest hazard for me. You see all these pictures here. Wind can be very devastating in the stronger storms. They can tear apart buildings. They can send a piece of 2x4 right through a tree under the right conditions. A lot of people think about wind when they think of hurricanes. Water is really what they don't think about, but they really should think about. The top left-hand corner, Robbie talked about different types of flooding. Well, this picture in the top left is people being rescued out of fresh water flooding from heavy rain. The bottom left is the water from the ocean moving inland, and that is storm surge. So water is really what kills the most from hurricanes. And since 1963 to 2012, half the fatalities came from storm surge alone. Another quarter of the fatalities came from that inland flooding from the rainfall. And other water-related fatalities we see offshore and surf. So we're talking about the rip currents and folks, if their boats capsize at sea and they drown. So 9 out of 10 people die from water and not the wind. Don't get me wrong, wind and tornadoes can cause fatalities in storms, but the biggest hazard for the folks living near the coast and the folks that are vulnerable from areas that could get flooding for rainfall should definitely take note and pay attention to what your evacuation plans are if a storm approaches. So we're going to show an example of storm surge. Hurricane Sandy was kind of a large, sprawling hurricane that made landfall in New England back in 2012. So this is a picture of Manhattan, New York. On a normal day, folks are walking around on the streets. People are driving their vehicles around. Pay close attention to this storefront here. So when Sandy moved inland, it brought ocean waters inland with it. And so it flooded the streets of New York City. And so we see water at least a few feet deep. Use the car as comparison here. Water's over halfway up the car. So folks that were probably in these buildings were trapped until the water subsided. That's one example of storm surge. Well, imagine if you lived even closer to the water, like on the beach, if your homes were within a mile or so, let's say. So what happens is, picture yourself in the water at the beach. A wave hits you, about a few feet high wave, it can knock you over. Water's very heavy. Moving water with waves on top of it are very destructive. They took these homes during Sandy and they moved them right off their foundations. Some homes just got moved, some got completely destroyed. That's the importance of why folks need to evacuate if their evacuation order is given, because you might not be safe in your home because the water can enter your home. So we talked about flooding rains. So flooding rains can happen from hurricanes. They can happen from any storm really, but they can happen from tropical storm. This is actually an example from Tropical Storm Allison, which never became a hurricane in 2001. So there's a picture of Houston, Texas on a dry day. So what happens is when you have very heavy rainfall, the runoff from the roofs and the streets inundate the ditches and the streams and the lakes in the area, and it has nowhere to go. And so it has to find somewhere else to go. And in this case, it found the Interstate 10 corridor. This picture you see, these are semi-tractors underwater, at least several feet underwater along the interstate corridor. And this happened again just a few years ago in Hurricane Harvey. Robbie also mentioned tornadoes and waterspouts. So what's the difference between a tornado and a waterspout? Waterspout simply is over the water. The bottom left-hand corner picture here, you see a waterspout over the water. The top left-hand corner is a tornado because it's over land. But yes, waterspouts can become tornadoes and vice versa. And the right-hand picture here, this waterspout is moving inland and becoming a tornado. And yes, they do occur during tropical storms and hurricanes, and they can be embedded in the rain bands, mostly outside the center of the storm. Robbie also mentioned waves and rip currents. So let's say a storm is a few hundred miles off the coast. It's a sunny day, but the storm is sending these swells towards the coast. So you have these larger than normal waves breaking on the coast. And what happens is, look at the bottom left-hand corner picture. The waves break along the coast and the wave action. The water goes back out to sea each time a wave breaks. What happens is there's shallow areas of water near the coast. And as these waves, water keeps pulling away, they find a channel. They start eroding an area. If you get stuck in that area, you're getting stuck in a rip current. And so you have to find a safe way to escape it. And that right-hand image here, you're showing break the grip of the rip. There's methods to escape the rip current by swimming parallel to the coast. There's ways to find out if rip currents are going to be around, even though it's a sunny day. The weather forecast offices can issue a rip current statement talking about the hazards. Or if you have a beach that has these beach warning flags, they can also indicate to you, even on the sunny day, that there's a high hazard, you should stay out of the water. So how do we predict all of these hazards? How do we know where these storms are going to go, how they're going to form, how strong they're going to be, how big they're going to be? Well, we have a lot of observations going on there all the time. Those can include observations from, let's say, land stations across the country. A lot of folks, even if you have a weather station at home, some of that data we can get into our systems and look at. There are ships out there that report data back to us very frequently. There's buoys, fixed buoys floating out there in the ocean that will report data to us also. We can monitor all of that at the Hurricane Center and at the weather forecast offices. Upper air data. We talked about weather balloons. Some of the weather forecast offices can launch weather balloons, and we get that data across the country a couple times a day. We can also have satellites. We have several satellites out there that look down on Earth and take snapshots. The bottom left-hand corner picture, and also Robbie showed you a loop of Hurricane Harvey. They take frequent pictures so we can see the size, the structure, and the movement of these storms. And we can actually tell what the intensity is based on an estimate of what the satellite is looking at with the storm. If the storm's close to making landfall, the radars, there's a lot of radars. The Weather Service has a radar all along the coastlines, and they can look at the storms and see the inner structure of them as they approach, so we can get even a better idea of the strength of the winds. We can also see tornadoes possibly developing as they're moving inland. Now, if there's a storm out there, we also have aircraft reconnaissance flying in and around the storms. And Nikki's going to talk to you about that here in just a minute. We take most of this data gets all pulled into these very sophisticated computer models that try to simulate what's going to happen with the storm. And so we're at the Hurricane Center, we're looking at all this data determining what the environment is of the storm, but we're also looking at these computer simulations to try to determine which simulations most representative of what's the reality of what's going to happen. So I said Nikki's going to talk about hurricanes, so I'm going to hand it off to her for a couple of minutes, and she's going to tell you about the experiences of flying into the eye of a hurricane.
Thanks, Andy. So yeah, like he was saying, we have aircraft reconnaissance, both the NOAA and the Air Force hurricane hunters that go out and they essentially survey the storms. So I am the flight director with the NOAA hurricane hunters, and I fly on board those 2 aircraft that you see in the pictures below. So the one on the left is Gonzo, our jet, and it flies around the hurricane and essentially surveys the environment that the hurricane is moving through. While the picture on the right, it looks a little bit shorter and stubbier with the black nose. That is one of our P3s. We have 2 P3s, Miss Picky and Kermit, and it actually flies straight through the eye of the hurricane. So both aircraft have very different uses, but are both very important to essentially getting that data that we need at flight level and also below the aircraft to go into those computer models that Andy was talking about for the forecasters to essentially make the best forecast possible. So the P3s are the ones that go through the eye of the hurricane. And you can see in that picture below, inside the eye of the hurricane, what it kind of looks like. So you get through, you punch through the eye wall, and then once you're in the eye, you see bright blue skies above you. The conditions go rather calm. Sometimes you even see some birds that got stuck in the eye of a hurricane. So in order to get through there, you have to go through a lot of rain bands and the eye wall, which is essentially the most dangerous part of the storm. But once you're in the eye, you see blue skies like you see in that picture. And then another thing that's important to keep in mind is the data that's being collected while you're going through the hurricane. So Andy mentioned dropsondes that fall below the aircraft, and that's actually getting a vertical profile of data as it falls through from the aircraft above all the way down to the ocean surface. And then as the aircraft actually goes through the eye too, we're collecting flight level data. So lots of data being collected. That picture you see of me there, I'm processing one of the dropsondes that fell out of the back of our aircraft. So we can talk a little bit more about that later on if you want, but essentially, this is just a small part of the team of meteorologists that are collecting data and putting the forecast together to keep you guys safe.
Thanks, Nikki. And as a large storm is threatening the United States, we have a lot of folks from the media that show up. On the left-hand pictures here, you're actually seeing a glimpse inside the Hurricane Specialist Unit at the Hurricane Center. Off to the right is the conference room next door, and you can kind of see off in the top left-hand corner of this image on the right, Hurricane Specialist Unit there in the background as well. So what folks are doing is they're getting television interviews, they're telling the information about what's important, what's the impacts. And so we're trying to convey, okay, this storm is going to particularly have a big surge threat or a big rainfall threat. We can tell those kind of details in the television interviews, and they get that information straight to you in your households. While we're working, we're also getting phone calls for radio interviews and newspaper interviews. We're also trying to send out information in social media to tell you what kind of impacts to expect from the storm. So there's a lot of different ways you can get the information to you at home from the Hurricane Center. You can go to hurricanes.gov to get the same some also up-to-date information as we send out the latest advisories every 6 hours. So we have Hurricane Preparedness Week coming up next month. So if you're asking questions like, well, am I in an evacuation zone? What kind of supplies should I get for hurricane season? Where can I go to get information specific to my area? There's a one-stop shop, weather.gov/WRN/hurricane-preparedness. And that link's going to be on the final slide here. We're going to let sit there in front of you for a few minutes. At this point, I'm going to actually hand it off back to Dan and to John, because I know you've probably been asking a lot of questions and typing those in, and they're going to try to field those to all of us here in the next 20 minutes or so.
Thanks, Andy. Appreciate that. Yes, we've gotten a lot of questions, so we've answered quite a few of those today. Some really great questions that have come in. I was going to take the first one and send it over to Frank, and then I'll let John, I'll let you pop on here after I ask the question. But the first question to you, Frank, is asking which hurricane in the last 100 years that have hit South Carolina was the worst? It hit the state the hardest.
Well, that would be Hurricane Hugo back in 1989. That's the last time that we had a Category 4 hurricane make landfall in the state. and was mentioned earlier in the talk, the track of it went right through the essentially the center of the state, not even into upstate. So we had the highest surge recorded ever on the east coast of the United States with that particular storm. The flooding, especially along and north of the Charleston County coast up to Myrtle Beach, was especially devastating. And then the winds were really bad inland as well. Wind gusts were up to 100 miles per hour all the way up to areas near Charlotte. So that was certainly the strongest hurricane that we've had in the last 100 years in South Carolina.
Thank you, Frank. Appreciate that. The next question is from Gracie in North Carolina. I wonder if her dad helped her with this question. It's a pretty tough one. I'm going to send this one to Robbie. So good luck, Robbie. How does climate change affect hurricanes?
Wow, that's a good question. So, there's a lot of research being done on how climate change affects hurricanes. And in truth, we just don't know all the answers yet. And that's why the research is being done. So there are some studies that say that storms are getting stronger. Some studies say that storms are occurring more frequently. But the hard part is that we really don't have a long record of hurricanes. We only have satellites since about back in the 1950s, and that's not that really long of a period. So it's very hard for us to know exactly how many hurricanes occurred before that time. We have a good idea because of ships that may have been in the way, but we just don't really know for sure. One cool study, or interesting study, I guess, that I've seen lately is that global climate change could be causing storms to slow down. And if that's the case, that means that areas are starting to get a lot more heavy rainfall events. And I think for you guys in the Carolinas and in Georgia, you've seen that. Think of storms like Matthew and storms like Florence. There's been a lot of bad flooding. So it's not just the strength of the storms we have to worry about, but it's also those hazards that we went over. How are they changing with the way that the climate is changing? And some studies suggest that we could be getting more heavy rainfall events.
Thanks, Robbie. I'm going to send this next question over to Carl. Your office is one of the offices that launch weather balloons, so had a couple questions about that. It says, do the balloons ever pop, and how do we find them when it lands?
Yeah, that's a great question. So firstly, normally we launch balloons twice a day. In the summertime, it's around 7 a.m. and 7 p.m. But ahead of hurricanes, we're launching them 4 times a day. And that's because that's the frequency with which we run a lot of our major models. So we're getting that really good data into the models for them to be able to use. So because of that, we're staffing up way ahead of hurricanes, whether they're going to affect Eastern North Carolina or not, because these models are really run on the global scale. So all that information's very important. So we're launching those weather balloons. They go up, and the importance of weather balloons is that they capture all of that data above the surface. So kind of like with Nikki flying into the hurricane, she's able to get that data that we can't get otherwise, because you actually have to get in there and get it. Well, the same thing with weather balloons, where above the surface, we don't have a lot of sensors. So the balloons give us that really important vertical information. So that information is gathered all the way up until the balloon pops. And that usually happens somewhere around 100,000 feet. So that's way higher than most airlines are flying. That's higher than the layer of the atmosphere where weather happens is called the troposphere. So that's way higher than the top of the troposphere. So it really gathers a lot of information throughout the what we call the vertical column. And we're looking at moisture and temperature and all that. And then so the balloon pops, and it actually has a parachute on it, and it comes back down to the earth very slowly. So if that balloon, the radiosonde, the part that collects the data, if that part lands somewhere on land, then it actually has an envelope in it. And if you find it, you can send it back. And what they'll do is, they call it refurbishing it, but they'll basically fix up the instrument so that it can be used again. So it is able to be recycled. And otherwise, they fall down very slowly. Sometimes they will end up in the ocean. They have as much biodegradable material as possible. So they try to take care of that. But that data really is critical for ingesting into the models and getting that important data above the surface when they're out forecasting hurricanes.
Thank you, Carl. Appreciate the answer. Nikki, the next one's for you. We've been flooded with questions of interest about the hurricane hunters. So I'm going to ask you kind of a combined 3-part question. So please take your time. So this is from Thomas, Sabrina, and Riley, I believe. And they says, what does it feel like to fly into a hurricane? Is it scary? And what's your favorite part of your job?
Ooh, I like the last question a lot because there's a lot of things I love about my job. But the first one, so what is it like? So if you've ever been on a roller coaster before and you kind of got that up and down feeling where sometimes your stomach just kind of comes up, when you're punching through an eye wall, essentially that's kind of like what it can feel. And every storm is very different. Sometimes you won't feel any turbulence at all. It'll be pretty steadily, a little bit bumpy, but nothing too drastic. And then other storms, you kind of move around quite a bit. So when you're on an airplane, you know, they always tell you to fasten your seatbelt. If you're in your seat, you're definitely with your seatbelt fastened when you're flying through, and you're prepared for those little bumps you might be feeling as you go through those stronger rain bands. If it's scary, so if you don't like roller coasters, it probably would be a little bit scary to you. In my opinion, we have a great team on board all of our aircrafts. So we have tons of different people besides just meteorologists. So when I'm on the plane, I'm making sure that we know where our strongest storms are, and that if we can go around them, we will. So essentially, we'll be looking on radar, we'll be looking at all of our data and saying, okay, let's go 20 degrees to the right or 40 degrees to the left and try to go around some of those stronger storms if possible. So that's my job on the plane. But we have our pilots in the front that are extremely well trained. They know exactly the airspeed you have to go through a certain storm. And then we have our engineers and technicians on the back. So we have a ton of different types of people on our aircraft that are all working together to keep our plane safe. So I think that takes away some of the scary part, is knowing we have such a great team working together. And then what's my favorite part? I just truly love my job. I think the best piece of advice I can give you as you're going through middle school, high school, is to figure out what you love and just make a plan to do that when you grow up. Because if you really love your job, no matter what day you're going into work, you're just gonna be excited to go. So I couldn't say one particular part that I love. I love doing outreach like this and being able to talk to you about this type of stuff. That's something I really enjoy. But in general, I just really love my job. I can't really pick out a part here or there. So.
Nikki, I saw a follow-up to that asking about how you know when you're needed to fly. And that was asked by Nick, and that comes from the folks like Andy, Robbie, John, and myself at the Hurricane Center. We actually request when we need a plane, and we'll fly a plane whenever a storm is heading toward land that's going to affect people, is when we'll ask the folks like Nikki to fly. So that's how that works. I had a question for Robbie. Some storm surge questions. Robbie does a lot of work at the Hurricane Center with our storm surge folks, and I would say he's one of our storm surge experts. So somebody's asking, what is the highest storm surge ever recorded for a hurricane? And that was from Thomas.
That's a really good question. I actually don't have the number off the top of my head, but I will say that there are some storms around the world that have caused some really high storm surges. In the United States, one of the most recent storms that's caused a really high storm surge was Hurricane Katrina, which hit Mississippi and Louisiana back in 2005. And when people went back after the storm to see how high the water got, they measured about 28 feet, I think it was, above sea level. So think about 28 feet. How tall do you guys stand? You're probably 4 or 5 feet or so, right? So think about 28 feet. How high is that? That's really high. And you can think, well, if a place can get 28 feet of water from the storm surge, then it's probably not safe to be in those areas. And so that's why we get people away from the coast when we think there's going to be a high storm surge event. I will say, I know there's some storms out in other parts of the world, like Bangladesh and India, where they get cyclones out there. And the way that their coastline is shaped, that makes the storm surge there really bad. And so there's been some really bad disasters where the storm surge was so high in those locations, and they don't necessarily have the evacuation type procedures that we have. And so unfortunately, we've seen a lot of deaths from those types of storms. So again, I don't have the exact number off the top of my head, but I know that at least in the United States, we've seen at least storm surges of 28 feet from Hurricane Katrina most recently.
Thank you, Robbie. Andy, I'm going to send the next question to you. The question was, what do we do at the Hurricane Center when it's not hurricane season?
Well, you're actually seeing one of the things right now. We do a lot of outreach. We have, for example, what we're not doing this year because of the circumstances, is we do what's called a Hurricane Awareness Tour, and there'll be stops across the United States where folks will take hurricane hunters, let people give tours, answer questions and everything. That's one example. There's conferences, scientific conferences we go to present some research and learn ourselves about new research that's going on to try to make sure we're getting those up-to-date technology into the building so we can forecast better. We do a lot of hindsight. So we look at storms that happened in the past year, and we write reports about them, and we learn from the storms that happened. And we send out these reports, and actually most of them are already available from this past year. So it's actually a very busy time of year. Some folks almost say it's the busiest time of year, especially when you're trying to finish some of the reports, you're trying to do a research project, you're doing outreach, and you're also trying to learn more for the upcoming season.
Thanks, Andy. A lot of great questions. I've got a lot written down. I sure hope I can get to all of these. I'm going to send this one over to Frank here. Oh, do you have something to add, Robbie?
I would just say I did a quick search, and I think that there was a cyclone that hit Northern Australia in 1899 that had over 40 feet of storm surge. So from what I've seen, that seems to be the record.
Thanks. So I'm going to send this one over to Frank. It's someone asking about, since you worked at the Charleston office for a while that I think covers the Savannah area of Georgia, and they're asking about, do you think Savannah is a little more protected from hurricanes than other coastal cities because it's tucked in a little bit, or is that just sort of a myth and that they're as vulnerable as anybody else?
Well, there's a problem there in that it is less frequent because of that, but they can still be very strong. As a matter of fact, there was a hurricane back in the late 1800s called the Sea Island Hurricane, which affected coastal South Carolina and Georgia, including the Savannah area. And that hurricane, unfortunately, killed 1,000 to 2,000 people. Of course, we didn't have the warning systems in place back then that we do now, but they're certainly still vulnerable in the Savannah area. And if you look at frequencies, one could even say that that area is particularly due for a pretty significant hurricane hit. So just because an area such as Savannah or anywhere else along the Georgia coast hasn't necessarily been directly impacted by a major hurricane doesn't mean that they can't, and one should always be prepared.
Great explanation, Frank. Thank you. The next one I'm going to send to Carl. So Carl, this question came in from two different students, both Sarah and Robin, that said they want to be meteorologists when they get older, and they want to get a head start. So they said, what courses can I take in middle school and in high school to get ready to become a meteorologist?
Yeah, so the first thing I would say is meteorology is really physical science, but to be a meteorologist really involves so much more than just being good at physical science. So specifically, physics and calculus are the two things that meteorologists, like the meteorology curriculum, focuses on as you get up into college. But when you're in middle school, I mean, I really encourage you to keep an open mind about different things. Take communications classes. I mean, what we're doing right now, you don't learn this in a physics or a calculus class. You have to be a good communicator because you not only have to make the forecast, but you have to be able to communicate it. Graphic design, everything we do now is on computers, and a lot of things that we do involves graphic design. So doing that, I mean, you really want to, as you get older, you can focus more on the physics and calculus, but while you're young, just try your best to be well-rounded. Really communications, those computer and technology aspects, try to focus on those, and don't focus too much on one specific thing, but try to be well-rounded. And there's so much that goes into being a meteorologist. I mean, you can be on TV, you can be behind the scenes, like most of what we do is behind the scenes. It's done on computers. We have people in our office who are programmers. We have people in the offices who maintain equipment. So any kind of electronics, something like a shop class or something like that, doesn't sound like what you think about when you think about meteorology. But I mean, there's so many crossovers between disciplines that us as meteorologists come across, that really just keeping an open mind and just trying to experience as many different things as possible is really my recommendation.
Thanks, Carl. That's a fantastic answer. I know there's a lot of stuff that we all started studying even early on to become a meteorologist and have the jobs we have today. So great job. I had a question, kind of a combined question here. And I also say, John, I know you're listening. We got to do the name question at some point. Get a lot of folks asking about how we name hurricanes, but I was going to save that one for a few minutes. I know that, Andy, I got a question here about One from Zachary asking, are there more hurricanes in the Atlantic or in the Pacific? And then someone named Will also asked, do we at the Hurricane Center forecast for typhoons? Are there other agencies that do that?
Okay, it's a great question. So statistically, the Pacific Ocean does get more hurricanes than the Atlantic Ocean does. They actually have two regions of hotspots. They have the typically Eastern Pacific, south of Mexico is a hotspot of where they develop. And then they do have hurricanes that affect the Central Pacific as well, but they really have more frequent occurrences over in the Western Pacific, where there's a large area of warm water. Our cutoff here at the Hurricane Center is at 140 degrees west, which if you picture a map, it's about halfway between the United States and Hawaii. The Central Pacific Hurricane Center takes over at that point, and they go a little further west into the Western Pacific. And then other folks, there's different regions around the world that take over outside that area. There's folks down in the Southern Hemisphere, and then there's folks over that take care of the Indian Ocean, and folks that take care of the Western Pacific. So different offices do cover different territories.
Thank you, Andy. I guess I'll send this one to Robbie. This one came from Gracie and also from a few others that asked questions about the names, as Dan mentioned. So how do we decide at the Hurricane Center when to name a storm, and where do these names come from?
Great, yeah, so we name storms once they reach tropical storm strength. And what does that mean? That means that the wind in the storm system has reached 39 miles per hour or greater. So before, when the winds aren't that strong yet, we haven't named it. And once it gets to 39 miles per hour, then we give it a name. So the name comes from a rotating list. And we have this list is every 6 years we rotate. There's a different list every year. We go through 6 years and then we start back at the beginning. And we just do this rotation every 6 years. And each list for every year is different. We alternate between boys' names and girls' names. And that does change every year as well. One other thing is that the names tend to be either English, Spanish, French, or Dutch origin, because those are the languages of the countries in our part of the world that get affected. So we have Spanish-speaking countries, English, and we do have some French and Dutch-speaking countries in the Caribbean. So those are the types of names we use. We at the Hurricane Center don't actually come up with the names. We work with a group called the World Meteorological Organization. And all the countries in our area are on a committee where if a storm causes a lot of damage or kills a lot of people, unfortunately, then all the people on this committee will vote whether or not to what we call retire that name. And that means we won't use it anymore. And if we retire a name, then all the people on the committee then vote on what name should replace that name. And in most cases, the replacement name will be the same gender, and we try to make it the same ethnicity as well. So if it was a Spanish name, then we'll replace it with another Spanish name in general if we can find one. And again, all those countries will vote on the new name, and then we tell everybody what that new name is. So it's not really the Hurricane Center, just us, that decides that. It's a bunch of different countries, our neighbors, that are living and working in this side of the world with us.
Thanks, Robbie. I just about out of time. I think I'll do this question, let John maybe then ask the final question for this morning. I saw an interesting question here asking from Allison asking, during a hurricane, do we have to sleep at the Hurricane Center? I can answer that a little bit, that occasionally we do have to stay there. We tend to work 8 to maybe 10-hour shifts. So there's folks rotating on and off of the forecast desk during a given day. But if the storm is threatening South Florida, that we do have to sometimes stay so that we can be sure that we're there. And Carl, I was going to turn it over to you because I know your office has been affected by more than one hurricane in the last few years. And you all, I know, have had to stay at the office for a rather lengthy period of time. So I'll let you talk about that, and then I'm going to throw it over to John for the final question.
Yeah, we have, Dan. I don't know if we can go back in the slideshow to the slide from our office. But so during Hurricane Florence, our office we're located, I think 5 miles or so from the ocean, but we're on a high point. So we're not really vulnerable to storm surge where we're at. But we do have rivers and stuff that surround us. So during Hurricane Florence, a large area got 25 to 30 inches of rainfall. So we were completely cut off. Forecasters couldn't even get home or get out more than about a block from the office. So we do, in situations like that, I mean, we do definitely have to sleep at the office. They don't have living quarters built into them. So it's really just whatever area you can find, you set up a cot or whatever you have. So the bottom right picture on this slide was during Hurricane Florence. I don't think anyone left the office for essentially for 3 days because of the flooding that was occurring around the office. Again, the office was high, it was dry, it was safe, but it was when you went out from the office that it was dangerous. So if it looks like a lot of people are wearing the pajamas in that picture, it's because a lot of them are. A lot of people had just woken up, a lot of people were getting ready to go to sleep, and it was really any little 6 foot, square foot area of floor that you could find that was fairly quiet, you would try to sleep on. And I mean, Florence was such a slow moving storm that's just kind of what it takes, and everyone was happy to do it. I mean, one thing as meteorologists is we really love our jobs and we really are passionate about what we do. So, you know, when a situation like that arises, you do what you have to do, and you know, it's all about just keeping watch. So I really like that picture, and I cherish it. It was really shortly after I had gotten to the office, so it was, I mean, we really, these offices, people who are there are really family. So yeah, during these hurricanes, it's not unusual to have to spend the night at the office, both for safety reasons and just to you know, accommodate the workload of what comes with it.
Thank you, Carl. I'm sure you didn't get much sleep while you were doing that, after all. I remember during Hurricane Irma, I slept in the storage closet because I was working overnight. Just find a place to sleep and ride it out.
Exactly.
So, Nikki, the last question goes to you. There's been lots of questions, as I mentioned earlier, and interest in hurricane hunters. So it is a two-part question. Have planes ever been destroyed in hurricanes? And why are they named after the Muppets?
So the actual history behind why they're named after the Muppets, I actually do not know. That's a good question. I'm fairly new to this job, so I'm gonna have to figure that out and talk to my boss about that one, and get back to you. So tune in next time. I'll have that answer prepared. But do they get destroyed? So like I was saying before, we have a lot of different types of people on our staff. So we have tons of technicians and people that know the aircraft back and forth. So for example, if we did have a stronger storm and maybe one of our sensors got clogged with some bugs that got trapped inside or things like that, they're always overlooking the plane, making sure that they have everything prepared the way it has to be before we go out and fly again. So, you know, you do have wear and tear like you would on your car on the aircraft. And our technicians are the best at what they do, and they make sure that before we go out for our next mission, that our aircrafts are up to par and ready to go. So in that sense, there's always maintenance being done. But destroyed, I don't think I would use that word.
Thanks, Nikki. And I wish we had another hour because I think we would have enough questions to continue answering them. Again, a lot of fantastic questions came in today. We really appreciate the interaction from you all, your attentiveness for staying with us this morning. Really do appreciate it. I did see one from Dylan that said, boo to both of us, Robbie, said, go Duke. So I have to throw that in there for him. But anyway, I'm not sure I can agree with the go Duke, but yes, there you go. So anyway, Robbie, I'll let you tell folks where they can see the recording of these after the fact, and I'm going to sign off and say again, thanks so much.
All right, yeah, thanks, Dan. So you'll see on your screen, there's a couple of websites you guys can access. The last one on there is our YouTube channel from the Hurricane Center, where you can watch this and all the other webinars that we're doing for kids in this series. There's also some other content on there about hurricanes as well. So please visit that, watch us again. And again, we're just really happy that all you guys decided to join us today. And I guess we're done. So I'm going to say goodbye. Everyone stay safe, stay healthy, and have a good day.
Yeah, and thanks, Nikki, Frank, and Carl for joining us today. Thank you very much.
Bye, everyone. Thanks.
Take care, everybody.